All right, we are talking about Module 26. So the good news is a lot of this module has topics from previous modules that you might have tested out of, or you can go back and get back pretty quick. So they're all listed here. These ones in green are ones that you have had in a previous module. So this just tells you where you could go back and find them. Okay, which leaves us with, I believe, 6 that we need to do in the video. Okay, starting with the first one, graphing a piecewise defined function problem type 1. And you did actually do in a previous module problem type 2. So you might remember that a little bit. Okay, usually problem type 2 is a little trickier than problem type 1, so this might even be a little bit easier. Okay, so if you remember, piecewise defined function will give you a function that changes on different intervals of x. Okay, so this particular one is -2 if we're between -3.5 and -2.5. Okay, and notice that we would include 2.5, but not the 3.5. So that's going to tell us that we would have an open circle on 3.5 and a closed circle on -2.5. That should be a -3.5. Okay, because it's less than versus less than or equal to. All right, and then -1, 0, 1, and 2. And this is going to be if we're between -2.5 and -1.5. This is what's called a step function, actually, and you'll see why in a second. Oh, I mixed it up on me a little bit. Okay, that one's just less than for both. And this one, 0.5 less than equal to x, less than 0.5, and 0.5 less than equal to x, less than 1.5. Okay, so get my grid going here. All right, we want to go. So our x's go from -3.5 to +1.5. And our y's go from +2 to -2. Okay. Let's see, I'll do my scale by halves here. Okay. All right, so start graphing here. First of all, our function is -2 if we're between an x value of -3.5 and -2.5. So it's going to look like that. Okay, that gives me a y value of -2 on that x interval. And again, whenever I see that less than or equal to sign, that's when I'm going to fill in the circle. Okay, and then it's going to be -1 from -2.5 to -1.5. And I will fill the circle here. Okay. Again, because in order for it to be a function, we could not have two closed circles when x is -2.5. So we have to know which interval the closed circle belongs to. So when we're at x of -2.5, it has to belong to the interval at -2. Okay. Oh, and I wrote -0. No such thing as -0. Okay. Between -1.5 and -1/2, we want to have it at 0. And we'll do the filled circle on neither of those because we don't have any less than or equal to, just less than. Okay. And then 1 from -1/2 to +1/2. And we're going to fill that circle. Okay. And then from 1/2 to 1.5, we're at 2. And we're going to fill that circle. Okay, so just be real careful about which circles you fill. You can do a quick vertical line test to make sure that you can't draw a vertical line and go through any 2 points. And then also notice this is, again, what's called the step function because it looks like a little staircase there. Okay, and all of these problems are going to be pretty similar to this. Okay. Yeah, these are looking pretty similar. Okay. All right. Our next topic then, we are going to graph we have 3 graphing parabola topics here. Okay. All right. So our next topic is going to be graphing a parabola of the form y squared equals ax or x squared equals ay. Okay. So take a little bit of notes here first. If we have y, so you guys are used to, first of all, y equals ax squared. Okay, so we're not used to having the a on the piece that's not squared, all right? But if it's y squared equals ax, okay, it's the y part that's squared. So if a is greater than 0, it's going to open this way. Okay. If a is less than 0, it's going to open this way. So that's what we call a sleeping parabola. All right. Again, we're used to the x piece being squared, so when the y piece is squared, it goes left and right rather than up and down. If we have x squared equals ay, and a is greater than 0, it's going to open up. And if a is less than 0, it's going to open down. Okay, and these two, they all have the point 0, 0. And then you can just get other points by moving out from that vertex, all right, whether it's left and right or up and down. So, for example, if we have y squared equals negative 3x, okay, so we know that it's going to be left or right, and since it's negative, it's going to open to the left. So it's going to look like our lower left corner guy there, okay? So we know that we can put in the point 0, 0. All right. Now, if we are looking at this, then the next thing we want to do is go up 1 and down 1. Okay. So if y is negative 1 and if y is 1. All right. Again, you're just going to go from that vertex up 1 and down 1. So if y is negative 1, then negative 1 squared equals negative 3x. Okay. So 1 is negative 3x, and x is negative 1/3. Okay, so when y is negative 1, x is negative 1/3. So let's go ahead and go by 1/3. That's going to make our life a little bit easier. Okay, so we'll have the point negative 1/3 for x, negative 1 for y. So negative 1/3, negative 1. Okay. And then if y is 1, same thing, okay? And that's because we have symmetry there. So you really don't even need to do the math for that, right? We know that if it's going to open to the left like that, we have a line of symmetry. Okay, so we can also plot the point negative 1/3 of 1. All right, and that's kind of a fat parabola there. Okay, remember if a, well, I'm going to leave it at that for now. Okay, we'll do another one here. Let's try get an x squared one instead of a y squared one. They keep coming up y squared. I keep clicking to get a new example, and they are all y squared. All right, I'll just do another x squared one. Okay. If it were x squared equals 1/4 y, Okay, you know what? I'll switch colors so that doesn't get confused with the other one. X squared, well, that looks bad. X squared equals 1/4 y. X squared equals 1/4 y. Okay, so that's going to be like this guy, the upper right-hand corner, because if it's x squared equals ay and a is positive. Okay, so again, we know our vertex will be at 0, 0. Okay, and we know that it's going to open up like that. So we can go ahead and do when x is 1 and negative 1. And again, like the one that we just did in the green there, we really only need to do one of those because we know that we're going to have symmetry. Okay, so if x is 1, then 1 squared equals 1/4 y. 1 equals 1/4 y. Okay, so then 4 equals y. So if x is 1, y is 4. And then we know because of symmetry, we'd also have negative 1, 4. And there's my skinny parabola, like that. Okay? All right. Moving on to the next one. We have a little addition to this one. So graphing a parabola of the form x equals a times y minus k squared, or y equals a, oops, this should be plus h. Y equals a times x minus h squared plus k. Okay, so if we have x equals a times y minus k squared plus h, the vertex is at hk. All right, and then again, just like before, if a is positive, it's going to look like, well, you know what? Not necessarily at the origin. If it's positive, it's going to look like this. So this would be HK. If it's negative, it's going to look like this. Okay. And then if we have y equals a times x minus h squared plus k, the vertex, again, it's at hk. It's a point. Okay. And if a, this is the one that you're used to, right? If a is greater than 0, oops, I keep on wanting to draw an axis there. It's going to open up. And if it's negative, it's going to open down. Okay, so it's very similar what we just did. It's just the vertex is not at 0, 0, but you're still going to move up and down 1 to get a point, or left and right 1 to get a point. Okay, so the example that came up for me was I have x equals 3 times y minus 2 squared plus 7. Okay, so the first thing I'm going to do is that the vertex will be at HK. Okay, that 2, it says y minus 2, so the 2 goes with the y. Okay, so that means the x coordinate is 7, the y coordinate is 2. Okay, so let's see here, 2, 7, let's go. Do this. Okay, so, oops, actually I need 7 too. Okay, 1, 2, 3, 4, 5, 6, 7. Let me move this guy over a little bit. Okay. All right, so the vertex is at 7, 2. 1, 2, 3, 4, 5, 6, 7, 2. Okay, and it's x equals with a positive a value, so I know that it's going to have this shape to it. Okay, So that means that I would want to go up or down from that 7, 2. So I will make y equal 3 or y equals 1. And remember, because of symmetry, I'm going to get the same x value for those. Okay, you can see in the equation, if I plug in 3 for y, I'm going to have 3 minus 2 squared, which is 1 squared. If I plug in 1 for y, I'll have 1 minus 2 squared, which is negative 1 squared, which is the same thing. Okay, so x will equal 3 times either positive or negative 1 squared plus 7. It doesn't matter because when I square it, it's going to be 3 times 1. So it's going to be 10. Okay, so I'll have the points 10, 3, and 10, 1. Okay, these are y values. This is an x value. So just make sure you get them in the right order. So I'm going to have 10, 1, and I'm going to have 10, 3. And my parabola will look a little bit like that. Okay. All right, my next one. Let's see, what do we got next? We are going to do graphing. All right, so another one of these guys, different form. We have graphing a parabola of the form ay squared plus by plus cx plus d equals 0. It's been a while since I've done these. Ax squared plus bx plus cy plus d equals 0. Okay. So for these, you just have to do a little bit of rearranging, and then it's going to follow the same rules. So what we want to do for this one is, I'm just double checking here to make sure that I have what you want to do. Yeah, okay. So you complete the square. Okay, so for example, here, I'll just write it first. Complete the square. Okay, so in the example, we have 3y squared minus 6y minus x minus 2 equals 0. Okay, and you can see the piece that is squared is y. So we're going to go ahead and get that x to the other side. Okay, and then we're going to complete the square with what we have left. So if you remember, you're completing the square. We factor out the coefficient of the y squared from the y terms. So we'll have 3y squared minus 2y, minus 2 equals x. Okay, all we did was factor the 3 out of those first two terms. If I redistributed the 3, I'd have 3y squared minus 6y. Okay, and then remember, we split that middle term. Okay, so we rewrite it as y minus 1 squared minus 2. We're going to have to balance something out here, equals x. Okay, again, remember you take half of that negative 2y. Okay, and then what happens is when we expand this, we'll have 3y squared minus 2y plus 1 minus 2 plus whatever. Okay, so 3y squared minus 6y plus 3 minus 2. And so then we figure out here that when we switched that, okay, right here, in doing that, we added in this extra 3 that we don't need. Okay, go back up to here. Everything matches except we have an extra 3. So we're going to take out the 3. Okay, and then everything works. So since we added the 3, we take it out. We're going to work our way back here. okay? So what we have is 3 times y minus 1 squared minus 5, okay? Again, it goes back to your completing the square. And then it just becomes like the previous problem, okay? So be real careful with that completing the square. You know, if you need to go back to watch the video on completing the square, you can search the syllabus to see which module that was in, okay? Oops, and I forgot my equals x. All right, so now we have x equals 3 times y minus 1 squared minus 5. So you can look at the previous one here. X equals a. With a positive a, it's going to look like that. Okay, so we're going to have something that goes to the side with a vertex at 5, negative 5, 1. Okay, so when we graph this, let's see, negative 5, 1. 1, 2, 3, 4, 5, 1. Okay, and then again, we'll go up and down. So we'll do y equals 0 or y equals 2. And again, either way, we're going to have x equals 3 times either negative 1 squared or positive 1 squared, so just 1, minus 5, which is negative 2. Okay, so we'll have the point x is negative 2, y is 0, x is negative 2, y is 2. And our parabola looks like that. Okay. All right. Our next one is word problems involving parabolas. I feel like we didn't do this yet. It's okay. Word problems. I guess it's just problem. We're going to be picky about the topic. Word problem involving a parabola. Okay, so for this one, we have a satellite dish, which you guys might be too young to have seen the big old satellite dishes like when I was growing up. If you have like the Dish Network or something, you might have a little satellite dish outside your house. They used to be huge, but they have this parabolic shape to them. The way a parabola works, basically, is that there's that foci, just like when you have the foci on the ellipses and everything. And when a signal comes in, the way that parabolas are shaped is they will always bounce towards the foci. It doesn't matter where they're coming in from. It bounces towards the foci. So it takes all these signals and concentrates them on the foci, and at the foci would be some sort of sensor that would pick them all up and like they'd all be together. So that's kind of how the satellite dish works. Okay, but in this problem we have a satellite dish, shape of parabola and viewed from the side. The dish is 40 inches wide. I'm sorry, 48 inches wide. Okay, so they tell us that. Let me get a little bit better of a. Make this a fat satellite dish there. Okay, this is the shape of it. And then this measurement, no, I don't want it to be fat. Okay, this measurement is 48 inches. Okay, and they say it's 24 inches deep. So this measurement is 24 inches. Okay, or on my drawing, they show it from the outside that this is 24. Okay. And how far is the receiver from the bottom of the dish if the receiver is placed at the focus? So I drew my receiver, in the middle there, but we've got a receiver somewhere. Okay. So they give you this little sketch, and then they kind of give you one that's a little bit better because it looks more like a graph. So they go ahead and do this. And if we draw in our parabola, oh, that's really bad. Let me fix that. Okay, so they point out that because of the dimensions, we want to put 0, 0 here, and then this would be at 24, 24. This would be at negative 24, 24. And then we don't know where that is. Okay, so, gosh, I'm forgetting because we did the parabolas before spring break. I don't think we did focuses for parabolas. So I'm going to pretend like we didn't. So your equation for a parabola would be x squared equals 4py. Okay. And this is a parabola that opens up. Or it could be down if p is negative. But the vertex is at 0, 0. Okay, and then you might be wondering, well, what does p mean? Okay, well, the focus is at 0p. Okay, so this looks like a really confusing problem, but it's really not bad at all, I promise. Okay, because all you need to do is plug in one of the points that you have and solve for p. Okay, in the one point that won't work is your 0, 0. You don't want to plug in 0, 0. If I plug in 0, 0, then I'll have 0 equals 4p times 0, and that doesn't tell me what p is because I just get 0, 0. So I can plug in 24, 24, and then I'll have 24 squared equals 4p times 24. Okay, and even this, you might be like 24 squared. I don't know what 24 squared is. You don't need to, because if we're doing 24 times 24 equals 4p times 24, get rid of one of those 24s. So 24 is 4p, so p is 6. Okay, so our focus would be at 0, 6, or it's 6 inches above the vertex there. Okay, so there's a lot of diagrams with these that might look a little scary, but it's just using that equation. Okay, and it looks to me like these are all very similar problems. Okay, they're all satellite dish problems. Okay. All right, and then we got one more topic here. We have classifying conics given their equations. This is kind of like the big lead up here. This is tough stuff, but it's good stuff. Classifying conics given their equations. Okay. So let's just kind of briefly go over the conics that we have so far, or all of the conics, because we've done them all. Okay. If it is a circle, it will be x minus h squared plus y minus k squared equals r squared. Okay, and we know that the center would be at hk and the radius r. Okay, an ellipse is kind of like a circle with two different radii, if you think about it. One radius in the horizontal direction, one radius in the vertical direction. So think about dividing that entire circle equation by r squared, right? Then you'd have a 1 on the right-hand side, but now it's a different r depending on if we're in the x's or the y's. Okay, so it would be something like that, where the center is at hk, and you move up and down a. Oops, I'm sorry. We would move up or down b. I'll erase that. And left and right a. And whichever one of those is bigger gets you to the vertex. Okay, the vertex is the farther distance. All right, and Alex is pretty picky about, well, a has to be greater than b. So in this way, the vertex would only be left and right. Okay. Your hyperbola is almost the same thing. Okay, the center, again, is at HK, and I'm not even going to write, you go left, right, A, up, down, B. Okay, and then depending, if we, this way, X is first, so we know that it would be like this. If Y was first, it would be like this. Okay, and then we have a parabola, which would be Y equals A times X minus H squared plus K. That's the ones that open up or down. Okay, and if it were negative, if A were negative, we'd open down. Or X equals A times Y minus K squared plus H. And those are the ones that would open left and right. Okay, so if A is less than 0, it opens the other way. So you should already have all your notes on these somewhere. Okay, but now what they're going to do is they're just going to give you a problem, and they're going to say, which one is it? And if it's a circle or an ellipse, they'll probably ask for the center. If it's a parabola, they'll probably ask for the vertex. They might even ask for the center of a hyperbola. They'll ask you, yeah, if it's a hyperbola, I believe if it's a hyperbola, circle, or an ellipse, they'll ask you for the center. And if it's a parabola, they'll ask you for the vertex. So they're basically going to ask you for HK. All right. That's what it looks like to me anyways. So we'll go through a few examples of these. So the first one we'll look at is 9x squared minus y squared plus 54x plus 6y plus 81 equals 0. Okay, and what we're going to do for all of these is complete the square. Okay, to get it in the right form and to be able to pick out that HK. So we're going to do 9x squared plus 54x. And we'll factor the 9 out of there. 6. And then we'll do the negative y squared plus 6y. Okay, so right away, we can see that this is going to be a hyperbola because it has an x squared and a y squared, and one is positive and one is negative. Okay, trick here is we want to factor out a negative 1. Okay, and then we'll just get that 81 to the other side. Okay. All right, now we complete our square. Okay, and then we know, so again, in the previous example I did, I know that I added something on to the left side, so then I subtracted from the left side. The other way that we can do it too is if we add something on the left side, we'll just add the same thing to the right side. Okay, so I know I added something there when I completed the square, so I'm going to figure out what I added and then add it to the right-hand side. And then this one will be y minus 3 squared, and it will also cause me to add something there. Okay, so again, to figure out what you added, you expand it. 9 times x squared plus 6x plus 9 minus y squared minus 6y plus 9. So I have 9x squared plus 54x. There's my 9x squared and my 54x plus 81. But don't get confused. That's not this 81. Okay, that's what I added. All right, and then minus y squared, good, plus 6y, good, minus 9. So I subtracted 9 from the left-hand side, so I'm going to subtract 9 from the right-hand side. So there we go. There's the two things that I added. Okay, so now I have 9x plus 3 squared minus y minus 3 squared equals negative 81 plus 81, so it's 0 minus 9. Okay, my last step is divide everything by -9. So what that means is my x term, but right now it's positive, is actually going to be the -1. Okay, so when I divide by -9, I'll have a positive y minus 3 squared over 9 minus x plus 3 squared equals 1. Okay, so my answer for this is going to be a hyperbola. And the center will be x is -3, y is +3. Okay. We'll do another example. Let's do -2x squared minus 4x minus y minus 3 equals 0. Okay. So again, we're going to complete the square, but you can see only the x is squared. So it tells me right away it's going to be a parabola. I know this is going to be a parabola. Okay, because all of the other ones have both x squared and y squared. All right. So again, we'll just complete the square here. And we're going to get that, well, let's just start with this. So we factor out the -2, and then we have x squared plus 2x, okay, minus y minus 3 equals 0. So then I'll have -2x plus 1 squared minus y minus 3 equals 0. So then I have figured out -2x squared plus 2x plus 1 minus y minus 3 equals 0. Okay, so -2x squared minus 4x minus 2 minus y minus 3. Okay, so by completing the square, again, I have my -2x squared, I have my -4x, I have my -y and my -3, but I also subtracted 2, so I got to add 2. Okay, so then if I go back to where I can, oops, yeah, I should have left my blank in there. I'm going to fix this a little bit. Okay, when I completed the square, I knew I added something extra in. Okay, and the extra thing I added in was a -2, so I need to balance that with a +2. Okay, so this should be 2, this should be 2. All right, so I have -2 x plus 1 squared minus y minus 3 plus 2, so -1 equals 0. So we'll just get the last step there would be to get to the y to the other side. So y is -2 x plus 1 squared minus 1. So if we have a parabola, it would be a parabola that opens down, and the vertex would be at -1, -1. Okay. And those are actually probably the two trickiest ones, are the hyperbolas and the parabolas. It's a little bit easier to complete the square for the circles and the ellipses. Okay, but that's all you do, complete the square. Once if it's a parabola, twice if it's a hyperbola, ellipse, or a circle, and then make sure you can pick out the right form there, and then your HK. Okay, and then that is it for module 26. Yeah, it is.